Welcome to this tutorial video on pipe shoe FEA automation. This video describes a novel approach of automating the finite element analysis of welded pipe shoes using ANSYS Workbench as the finite element tool. My name is Lotanna and I am a mechanical engineer at Worley. The current standard for performing the finite element analysis of a welded pipe shoe is completely manual and takes approximately 2 hours to complete. This manual methodology is tedious and rife with the possibility of mistakes that could happen at any step along the process, such as the CAD modeling, meshing, or boundary conditions definition. However, the new methodology described in this video automated the manual process and therefore eliminated the possibility of errors and significantly reduced the modeling time from 2 hours to just 3 minutes. A significant 98% improvement. The pipe shoe finite element analysis in ANSYS begins with the geometry component where the CAD model is developed. The CAD model is transferred from the geometry component to the mechanical model. Within the mechanical model component, the material's properties are defined and assigned to the pipe shoe assembly components. Next, the coordinate systems, boundary condition, remote points and contacts were defined. Finally, the FEA model was meshed. After meshing, the FEA model is transferred to the steady-state thermal component from the mechanical model component. Within this component, thermal loads, such as the ambient temperature, the ambient convection loads for pipe, shoe, and beam are applied, and finally, the pipe bore convection load defined. The final step was to link the static structural component to the steady-state thermal component. Within this component, the structural loads, such as the anchor restraint, pressure and pipe end forces were applied. Then, the thermal loads were imported from the steady-state thermal component and applied to their respective load steps. Finally, the model was solved, beginning with the steady-state thermal. The run FEA model step time to completion depends on the computer hardware's quality. Using the automation tool required just 4 steps. Step 1. Open the pipe shoe tool, FEA extension, from the ANSYS Workbench ACT start page. Step 2. Define the pipe shoe assembly geometric properties. The geometric properties and dimensions are automatically assigned per my company's pipe shoe standard. The geometry was automatically generated in SpaceClaim. Step 3. Assign the material properties to the pipe shoe assembly components. This process takes a bit of time to complete and, behind the scenes, materials XML files are imported into the mechanical model and assigned to each component. Then the coordinate systems, symmetry region, contacts are defined, and finally, the FEA model is meshed. Step 4. Define the thermal and mechanical loads. The steady-state thermal and static structural components are linked and the loads defined. Other automation tools are available, such as the ASME bolted flange assembly (FEA) tool, which generates the FEA model for ASME B16.5 bolted flange assembly, and the ASME bolted flange assembly CAD tool, which generates the CAD model for ASME B16.5 and B16.47 bolted flange assembly. And finally the API 579 Part 3 tool that automates the brittle fracture assessment and reporting per API 579 fitness for service code. For questions on these automation tools, please contact me via my email address or my LinkedIn mail, and also check out my LinkedIn profile for articles and resources.